This video is going to be about levers. A lever is basically a bar that is free to pivot or turn around a fixed point. And so I can draw basically a simple, typical lever here with some amount of a load on it. And so the fulcrum is the fixed point on the lever system. So this item here, almost specifically, the point at the top would be the fulcrum. The input arm, and so let's put sort of an input force here. The input arm is going to be the distance from the fulcrum to the point where the input force is applied. So that is here. Input. And the output arm is going to be the distance from the fulcrum to the point where the output force is exerted. And so therefore that is going to be the output, the length of that output. So here our input is down on the right and our output would be up on the left. The output force produced by the lever ultimately depends on the lengths of the input arm and the output arm. There are three main classes of levers. The first class lever is, or a class 1 lever is basically what you would typically think of a lever. And it's sort of the lever that I drew on the last page, where the fulcrum or the pivot point is in between the load and the effort. So the load and the effort are on either side of the pivot point. And an example of this is when you use like a screwdriver to open a can of paint here. Your effort would be down this way. So you can put an E for effort. And the load is this can top here. And so the load is going up that way. And at some point in the center by which you are going to be rotating this is going to be, your pivot point is going to be your fulcrum. A second class lever, the class 2 lever, is where the fulcrum is at one end, the load is in the middle, and the effort is all the way on the far end. So the load here is in between the fulcrum and the effort. An example of this is a wheelbarrow. Okay, the effort that this gentleman is putting on the wheelbarrow is up on the end there. The fulcrum is the wheel of the wheelbarrow, and the load, in this case, is this cute little puppy dog here in the wheelbarrow. And so this makes it slightly easier to lift whatever the load is by using this sort of lever and not just lifting the load straight up on its own. A class 3 lever looks similar to a class 2 lever, except that the effort and load are switched here. The effort is closest to the fulcrum and the load is on the opposite end. A large example of this, or a big example of this, are going to be lots of sports equipment. In this example, we have a baseball bat. And so you could sort of imagine that when the bat hits the ball here, that the ball will ultimately go this way. The force is exerted by this individual's right arm going the same direction. And the fulcrum, if I change colors here, the fulcrum is actually going to be this person's left arm, the point at which it is rotating around or pivoting around. So ideal mechanical advantage of a lever will be calculated by taking that length of the input arm in meters, as is typical with our lengths, and the length of the output arm in meters. Now, of course, technically, units don't matter here. Units don't matter as long as they're the same. So if my length of the input arm is in centimeters and the output arm is in centimeters, that's fine. But if one of them is in feet and one of them is in inches, I need to convert them so that they are the exact same unit, because they ultimately cancel each other out anyway.